All right, Thursday. So let's take a look at what we need to do. I think this is actually a pretty easy day for you guys. Let me share this with you. Oh, I am sharing it. Cool. So current work. Review combined gas law. So I'm going to do 2 or 3 problems. If you want to watch them, you can. Answer any questions students have for tomorrow's combined gas law homework and its early release. So tomorrow, basically yesterday, today, and tomorrow, you need to complete this gas law homework, combined gas law homework. And basically, it's just the problems similar to what we have. P1 V1 equals P1 V1 over T1 equals P2 V2 over T2. So let's just take a look at a few of these. Are there any in particular that you would like for me to do? About 3 and 4 on this. David, did you get Davis? Did you get my message?
Yeah.
All right, cool. A gas occupies a rigid 36-liter container at 29 degrees Celsius and 212 kilopascal. So right there's V1. That's close to T1. 29 plus 273.15.
The answer is 302.15.
There's our T1. Here's our P1. So we got that. Assuming the volume can't change. We don't even need V1 because V1 and V2 are equal to each other. What temperature in Celsius, we're looking for T2, we don't know that, is needed to give a pressure of 500 kilopascal. So that is P2. Any question about how I determined all of that? Basically, you look at the unit, you use words like at and to connect all these together and say that they're initial. You use words that like is needed to give a pressure of this to show that those two things are connected. So P1 over T1 equals P2 over T2. Whether you're going to use your mathematical algebraic skills to rearrange this equation so that it's ready to solve for T2. So T1 goes at the bottom, T2 goes at the top, T1 goes at the top of the other side. So now we take this 500 kilopascal times 302.15 Kelvin divided by 212 kilopascal. 500 times 302.15 divided by 212.
It's about 712.6179.
Kilopascal cancel out. And we get, excuse me, we get 712.6. That's Kelvin though. 712.62 minus 20.
The answer is 600.
No. 712.6 minus 273.15.
The answer is 439.45.
So we get 439 degrees Celsius because it asks for them in Celsius. Keep that in mind. You cannot keep this 29 degrees Celsius when you pump that into the equation. You must change these always to Kelvin. Kelvin is an absolute scale. Celsius, unfortunately, has negatives, which means that it's not absolute. A compressed air cylinder holds 10 liters of air at a pressure of 16.7 atmosphere. What volume will the same gas occupy at 0.950 atmosphere? So there's volume, there's pressure, V1 and P1. Here is P2. P1 V1 equals P2 V2. Temperature is not mentioned, so we assume it is constant. We want V2. So we divide both sides by P2. 16.7 times 10 divided by 0.950.
It's about 175.7894.
175 liters. So that makes sense. The volume went up, so the pressure went way down. If it's bigger, if the walls are further apart, then that means that the particles are not going to be able to hit the wall as often. Therefore, the pressure will be much lower. We have 2,941 liters of CH4 at 6.70 atmosphere. What is the volume of CH4 at 3.35 atmosphere? So we have V1, P1, P2. P1, V1 equals P2, V2. We're trying to solve for V2. So we divide both sides by P2. 2,941 times 6.70 divided by 3.35.
That would be 5,882.
Again, the pressure went down, so the volume must have gone up. That's all I got. If you want to get out of here and get that combined gas law homework done, I know that you guys have kind of a more miserable day than the others with being sophomores and having to do the personal project. So by all means, get that done. That way you can have all day tomorrow off. I am totally cool with that. Just drop into the Zoom tomorrow. I might have a video to show you, and then I'll let you out tomorrow to do the same. But if you want to stick around, I'm willing to answer any of these questions that you have, or any of the other questions that you have.
Can you show the answer for 7 again? Because I just finished it.
Which one?
7.
Yep.
On 13.
5,882. Actually, it would not be that. It would be 5,880 with significant digits.
Okay, yeah.
Is that what you got?
Yep. Thank you.
You're welcome.
Thank you.
You're welcome. You want to see any of these, Amari? Are you good?
I'm good. I'm just trying to learn psychology and kind of it.
Yeah. Take care.
You too.
Bye.